How does the concept of Qliphotic shells as subspace quantum information vortices challenge or expand traditional quantum mechanics? Associating the ancient Kabbalistic idea of the Qliphoth with the modern-day science of quantum mechanics is merely closing a some 4,000-year-old semantic loop in the study of fundamental ontology. While most of the Golden Age Greek philosophers of note followed Democritus in the pronunciation of atoms as being the smallest, most fundamental unit, the Hebrews taught the concept of the qliphoth as what would come to be called corpuscularianism, or the belief the smallest comprehensible unit of matter is the divisible corpuscle rather than the indivisible atom. Corpuscle theory of matter remained a parallel, yet less well-known, alternative to atomism until it was found by Newton, who ascribed it to energetic light. Einstein proposed the photon as a quantum of energy with near zero mass traveling at light speed, with the particular concept of a quantum being distinct from an atom in that an atomic system contained, per definition by that point, at least one electron charge orbiting a quark-gluon plasma nucleus, and all these smaller composite elements were considered quanta. As of the last I checked, QM still considers photons and all other such quanta to have particle-wave duality, providing them, in a sense, both a solid particulate form as a particle and an empty, hollow form as a wavelength, which harkens back to the original descriptions of corpuscles or the qliphoth as being shells or shell-like, containing a void, alike empty vessels. The Hebrew term qliphoth, or kellipot in Greek, refers specifically to shells, but the old Roman origin of the modern term for a quantum merely referred to a small measure of any given substance, essentially alike the Greek term an iota. So the term a quantum, used to refer to these particle wave packets nowadays, originally referred to a minuscule weight of any common denomination of currency for barter. At that time, the metal coin had not been invented yet, so the primary means of token exchange were cowrie shells. Thus, in a very literal sense, one could have a quantum of qliphoth or an iota of kellipot, as this is merely ancient slang for being poor, like being down to the last dime or even the least red cent may be a similar euphemism today. Nowadays, we can still use the concept of the qliphoth in its corpuscular sense to signify the particle-wave duality in our current understanding of QM. There are, of course, quanta that are more matter-like, bosons, and other quanta that are more energy-like, fermions. However, the commonality to all of them is the information of their spin. Bosons have integer spin and fermions have fractional spin, but both are measures of the same basic force, spin. Therefore, it remains likely that the information of spin will eventually be found to have a higher dimensional particle-like component, presumably similar in pattern and form to the various known quanta. In short, if all extant quanta particle wave packets are considered shards of the fallen shells, then perhaps the quantum-like shape signifying elementally unifying spin may be considered the shattered shards reassembled and the broken vessel restored. Indeed, the shape of a quantum of spin may be simply a torus, restored by averaging the spin of all broken quanta into a single fixed shape. Another term for the torus shape is a hypersphere.